So we'll sometimes define rotation gates around arbitrary axes. Of course, I can think about a change of basis. I can think about what any coordinate system that I'd like here. So as a note, we'll sometimes define the normal vector n hat to be nx, ny, and nz. This will be a unit vector with 3 real number coordinates, nx, ny, and z. So it's just pointing in some other general direction on this block sphere, right? The x-axis would be the coordinates 1, 0, 0, right? If we're starting with x, the y-axis would be 0, 1, 0. The z-axis would be 0, 0, 1. Okay? But we can be general now, and we can say we want to rotate about some general axis, which we'll call n hat, indicated by this unit vector. And then we can do that rotation r sub n hat now. It's not x or y or z. It's whatever the direction defined by n hat is, as the same way, so as a function of some angle theta, e to the minus I theta n hat dot sigma as a vector over 2, where I need to explain to you what I mean by this dot notation. So this just means nx times poly x plus ny times poly y plus nz times poly z. So think about collecting or stacking the poly x, y, z matrices in a vector which we call sigma, and then we have n hat in this vector, and so evaluating that dot product would give you a new matrix that looks like this.